So we're going to start talking about imaginary numbers. Imaginary numbers are numbers on the imaginary plane. They do have uses. We just don't use them in regular math. And that's just because it's like another dimension to what we're doing. So an imaginary number is defined as a number whose square, whose square is -1. Okay, what that means is that I squared would be equal to -1, which also means that if I squared is equal to -1, and I take the square root of both sides, then I would be equal to the square root of -1. And that's one of the big things too. So these two ideas are extremely important. You're going to defer back to that. So I squared is -1. For today, for radicals, this is what you need. Okay, anytime you see the square root of -1, it becomes an I. It's an imaginary. Okay, so imaginary and real numbers together make the setup of what is called complex numbers. So complex number is any number of the form a plus bi, or you could do bi plus a, where a and b are real numbers, okay? And so a complex number has two parts. It has a real part and an imaginary part, okay? And so we have this little hint right here. So it says, for any non-negative real number, the square root of -x is I radical x. We're going to think about that in a little bit, in a different way though. So right here, in my example, is radical, and the square root of -9. Well, the square root of -9, well, that's the same thing as the square root of 1 times 9, like we just did in the previous lesson, which is the same thing as the square root of -1 times the square root of 9. Now, as I said, back up here, right here, I know that the square root of -1 is I, and I know the square root of 9 is 3. So my answer for this is simply going to be 3i. That's it. That's all you have to do to simplify. So we're going to be simplifying basically the same way we were in the previous section, except we're going to add an I to it. So again, procedures are going to be the same. I just have 4 practice problems here. So this is simplify the radicals below. So I'm going to go through. I'm going to rewrite this. This is the square root of -1 times 5, okay, which is the same thing as the square root of -1 times the square root of 5. Now, over here, I'm going to break 5 down into prime factors. Remember, your prime factors are 2, 3, 5, 7, 11. So I start with 2. Does 2 go into 5? No. Does 3 go into 5? No. Does 5 go into 5? Yep, 5 goes into 5 once. 5 is a prime factor. That's it. I can't do anything with this. This cannot be simplified because I have no doubles underneath there. So I know that the square root of -1 is I, and then I have just my regular radical 5, and that's your answer. Okay, you can't simplify this anymore. So it's the same procedures we were doing with a previous problem. You just have to put an I next to it. That's all. So for this next one, I break it down. I know that's going to be -1 times 196, which is the same thing as the square root of -1 times the square root of 196. Okay, I break 196 down just like I did in the previous. So I think about my prime factorization. Is 196, can you divide it by 2? Yes, that is going to be 98. Can you divide 98 by 2? Well, 98 divided by 2 is 49. 49, I can't divide by 2. I can't divide by 3. I can't divide by 5. Can I divide it by 7? Yes. 7 times 7 is 49. And then 7 goes into 7 once. So I have my 1 here. So I know 196 is 2 times 2 times 7 times 7. Okay, so I know this is going to be I, and I know 196 is 2 times 2 times 7 times 7. I know I'm going to bring a 2 out. I know I'm going to bring a 7 out. There's nothing left in here, and I'm just going to bring down my I, and so my answer is 14I. All right. Let's go do another one. So this one right here, I do have a 3 on the outside. I just kind of leave it down in the bottom here just to remind myself that there's going to be a 3 there when I simplify. I know radical 80 is -1 times radical 80. So I know this right here, I know I'm going to have an I in it. Okay, so now all I have to do is simplify my 80. So I say 80, and I say, okay, well, does 2 go into 80? Yep, 2 goes into 80 40 times. Well, does 2 go into 40? 2 goes into 40 20 times. Does 2 go into 20? Well, 2 goes into 20 10 times. 2 goes into 10 5 times. Okay, 2 doesn't go into 5. 3 doesn't go into 5. 5 goes into 5 once. Okay, so I'm left with my 1. And so my radical 80, or excuse me, my radical 80 is 2 times 2 times 2 times 2 times 5. Okay, and I look for my doubles. I say, okay, so here I have a double here, and so I know that I'm going to have a 2 on the outside. I have a double here. I know I'm going to have another 2 on the outside. What's left on the inside? Okay, it's just going to be your radical 5. I multiply all of my numbers out. So 3 times 2 is 6. 6 times 2 is 12. I have 12. I have I radical 5. And that's going to be my answer. All right, very last problem. Alrighty. Okay. I know I'm going to have a -4, so I'm just going to remind myself that I have my -4 here. I also know that this is -1 times radical 192, and I know that the square root of -1 is I, so I know I'm going to have an I. Okay. 192. Okay, so now I have to worry about this 192. So I do 192 divided by 2 is 81. 2 doesn't go into 81, so I look at my next prime number, and my next prime number up here is 3. 3 does go into 81. 27 times. Does 27 times. Does 3 go into 27? Yep, 9 times. Does 3 go into 9? 3 times. 3 goes into 3 once. And so I know 192 is 2 times 3 times 3 times 3 times 3. I look for my doubles, because those are numbers that I can take the square root of. I have 2 3s here, so now I'm going to bring a 3 out. I have 2 3s here. I'm going to bring a 3 out. 2, there are no doubles. That's not a perfect square then, so I just leave the 2 in there. And then I multiply it out. -4 times 3 is -12. -12 times 3 is -36. So it's going to be -36i radical 2. And that's how you